I apologize, it's happened to me again. I really was trying to make this not happen, but I'd run out of storage. I really apologize. So this is just a continuation of the homework. So 21.4.2. So for Q, I went and solved this out, but it had cut out. So we're going to get a value of 5.20 times 10 to the negative 9th coulombs. And I left it in coulombs for the problem, but you could say nanocoulombs since it's to the negative 9. That is our charge for Q2, which is the solution for part D. So go on to the next problem, 21.4.3. Simple problem, Q1, 6 nanocoulombs at, this time we're given x0, y 0.2 meters, Q2, negative 6 at the exact opposite, so comma, negative 0.2. Q3 nanocoulombs at, where is it? 0.150. So we have two parts, E and F. E wants us to find the net force, and F wants us to find, oh, sorry, not that. Wants us to find the angle. Okay, so in this case, let's draw it out. So again, these are both going to be equidistant. So this is 0.2, negative 0.2, Q1, Q2, and then we have Q3, 1.5, Q3. And since these are both equidistant from each other, they're both going to be the same x and y distance away from Q3. So we can go ahead and calculate, I'll just say R1, comma 2 is equal to, go back to this. So we have, yeah, so it's going to be 0.2 plus or minus, but since that's squared, it won't exactly matter. So we have 0.2 plus, and then from Q3, 0.15 square, then we get 0.25. So, okay, so we need to find F net, so that means we need to find F1 on 3 and F2 on 3. So let's do that. 3, let's go back to this format. R1 squared. And again, this is very similar to before. This is 9. Negative 9 from nano to regular coulombs times 2.5. Yep. And then we know that distance is going to be 0.25 as just calculated down here, squared. And that will give us nope, not negative. Get 2.16 to the 6. Newtons. Then F23 is essentially the same exact thing. We're using that same R value because we know that they are both equidistant, except for instead of 6, we are going to use, let me see here. Actually, no, these would be, yeah, these are going to be the same. So these are actually both going to be the same since it's just a difference in charge, but we're doing the magnitude up here. So I'll say F1, comma 2, 3. Actually, I'll just 1, 3, 2, 3 is equal to that. So F net, what we're looking for, is equal to let me see. We do. Okay, yep, so we have 2 times F1, or I'll say F13, comma, or 23, and then, okay, yep, and then from here we're going to do times sine theta, and theta is opposite over hypotenuse, so that is going to be, what is that going to be? Okay, so that's going to be 2 times 2.16 times 10 to the negative 6, and then sine of opposite over hypotenuse is, yep, 2, 5, and then that is going to be yep. Yes. Remember this being slightly different. Double check my work. Oh, why did that happen? Okay. Yeah, so recalculate that. So it's going to be, instead of 30, I just redid it, and it's approximately, again, I'm converting that to micronewtons. That's just the format the problem had wanted it in, or the units. So